best hyperparameter value that produce a model with a low generalization error, say just 5%, means 95% accuracy. So you launch this model into production, but unfortunately it does not perform well as expected and produced 15% of error. What just happened? The problem is that you measured the generalization error multiple times on the test set, and you adopted the model and hyperparameter to produce the best model for that particular set. This means that the model unlikely to perform as well on new data. The common solution is that problem is called holdout validation. You simply hold out part of the training set and evaluate several candidates model and set the best one. Means आप इनको वैल्यूज़ चेंज करके आप डिफरेंट वैल्यूज़ के ऊपर लगा सकते हैं, क्योंकि जब आप मॉडल ट्रेन कर रहे होते हैं तो वो रैंडम नंबर उठा रहा होता है, आप कोई स्पेसिफाइड नंबर नहीं उठा रहा होता. द न्यू हेल्ड आउट इज called the validation set. Or sometime the development set or dev set. More specifically, you train that basically validation set is a pre-exams. Means I will explain you. If you give the exam papers of 9th and 10th, then in our school there are pre-exams that are just like real exams but no real. This is our testing. So in machine learning field we will call that pre-testing or pre-exams is called validation set. More specifically, you train multiple models with various hyperparameters on the reduced training set. The full training set minutes the validation set, and you select the model that perform best on the validation set. After the holdout validation process, you train the best model on the full training set, and thus giving the final model. Lastly, you evaluating the final model on the test set to get the estimate of the generalization error. This solution usually work quite well. However, if the validation set is too small, then the model evaluation will be imprecise. You may end up selecting the suboptimal model by mistake. Conversely, if the validation set is too large, then the remaining training set will much smaller than the full training set. Why is this bad? Well, since the final model will be trained on the full train set, it's not ideal to compare candidate model trained on the much small training set. It would be like selecting the fastest sprinter to participate in the marathon. One way to solve the problem is to perform the repeated cross validation using the many small validation sets. Each model is evaluated once per validation set. After it is trained on the rest of the data by averaging out all the evaluation of the model, we get a much more accurate measure of its performance. However, there is a drawback. The training time is multiplied by number of validation set. This is a drawback of using the validation data set. Data